Okay, guys, back here again for your second video. Hopefully you're able to find those and see the answers posted. Now we're going to use that skill in order to find trigonometric form of complex numbers. And so you have, this is complex form, a plus bi. What we would like to be able to find is the trigonometric form. And that is great use, as you're going to end up seeing next week exactly why we use that. There's some pretty complicated things with it to make it easy for you because you're super smart. But notice this guy right here, the graph of this. You'll remember we drew that line. And if you remember, we were over A units. We were over A units. And then we were up B units. And so what we end up doing is, in order to write it in a new form, instead of A and B, we replace it with R and with theta. And in this situation, this is R. And from the video you watched earlier, you recall that R is just simply the absolute value of Z, which we call the modulus. The way we find that R value is the square root of A squared plus B squared. So no big deal there, right? Yeah, I mean it's plain to see. That's something you've seen before. So what about theta? How do we find theta in this situation? Theta is an angle, okay? All right. And so in this situation here, as we want to find theta, we have to kind of determine something that's special about A and B and theta. If you consider this as a triangle, and that happens to be the opposite, and that happens to be the adjacent, which of the three trigonometric functions, sine, cosine, or tangent, has to do with opposite and adjacent and theta? You're correct, that would be tangent. Namely that the tangent of theta is equal to B divided by A. So we have two really important things that we're going to use here. And I'm going to show you kind of how we take those and then write it in trigonometric form. We're going to take this A plus BI thing, and we're going to replace A with something else. Okay? Replace A with something else. Come back to this drawing here, and as you consider A and R and theta, which trigonometric function would deal with A, R, and theta? So we have the adjacent, we have the hypotenuse, we have the angle, and you're right, cosine. Namely that cosine of theta is equal to, the cosine of theta is equal to the adjacent, which is A, divided by R. Last one I'm going to do is I'm going to consider B. B and R. Which trig function deals with B, R, and theta? Sine, cosine, or tangent. Well, that's the opposite. That's the hypotenuse, and that's the angle. So that's going to be sine. The sine of theta is equal to B divided by R. Well, if we want to get rid of this A and put something else in its place, we need to know what A equals. Well, look at this guy right here. It says cosine of theta is equal to A over R. So if I multiply both sides by R, I get R cosine of theta is equal to A. So therefore, instead of A, I can write R cosine of theta. R cosine of theta. Plus, now I don't want to have B. I want to get rid of B. Well, if you look at this one right here, you see we multiply both sides by R, we get R sine of theta is equal to B. So that's R sine of theta and then we have that times I thing on the end there. So these are the same things. This is what we call complex form, and then this is what we call trig form. But we modify that trig form a little bit. If you notice, what do they both share in common? They both have a r. Very good. So I'm going to factor that r out, and I have cosine of theta then, plus, and I like to write the I in front of sine of theta. When I say I mean all mathematicians. That's standard form for a trigonometric form of a complex number. R times parentheses cosine of theta plus I sine of theta. So that's our trigonometric form. Where R, you want to know how we come up with R? It's this guy right here, square root of a squared plus b squared. You knew that. And then how do we come up with theta? Well, it's right here. Tangent theta is equal to b divided by a. Tangent theta is equal to b divided by a. So there you have it. That's a general example. Let's do a few to make sure that we can actually do this. So we're going to do 3 examples here. Okay. Example 1, we are going to place this number into trigonometric form. Place this number into trigonometric form. We have 2 plus 2i. We need 2 things. We need r, and we need theta. Once we have r and theta, we can then place it in our trigonometric form. How do I find r? I do the square root of a squared plus b squared. That's the square root of 4 plus 4, or the square root of 8. What is the square root of 8 simplified to? Well, the square root of 8 simplifies to 2 roots of 2. 2 roots of 2. So, if we want to take this and write it as r cosine of theta plus I sine of theta, notice that r ends up being 2 roots of 2. Now what we need is we need the angle. So what do I put for that theta value there? Well, we like to graph it and kind of figure it out. So if you consider 2 plus 2i, which quadrant will 2 plus 2i place me in? First, second, third, or fourth? Very good. First quadrant. So first quadrant. There I have it. Okay, so I'm in the first quadrant. To figure out the angle, we solve tangent of theta is equal to b divided by a. b, which is 2, divided by a, which is 2. So 2 over 2, or tangent of theta, is equal to 1. Where is tangent of theta equal to 1? Where are both the x and the y values of the terminal points the same? And a lot of you guys remember from what we talked about, if you inverse on your calculator, you get 45 degrees. But we leave our answers in radians. So what is 45 degrees in radians? It is pi divided by 4. That's our angle. You can tell 45 degrees, which is pi over 4. So 2 roots of 2 times the cosine of pi over 4 plus I sine of pi over 4. That is trigonometric form of a complex number. There you go. That's the first example. We're going to do 2 more. And by the way, not only are we going to do 2 more of these examples here, but your next video is going to be an extension of this. So we're not going to learn anything new on the next video. We're going to practice it again and make sure that you guys are feeling good to go because this takes a little while. So don't be afraid if you got to reach out to me. You can always hang out over Google Meet and figure some things out if we need to. Complex form of -3 we got example 2 of -3, and we are going to do plus 3 roots of 3i. Notice the I is not under the square root. Okay, so there we have it. I need to find two things. I need to find r, and I need to find theta. How do I find r? I use the square root of a squared plus b squared. So -3 squared plus 3 roots of 3 squared. -3 squared is 9. And if I square 3 roots of 3, 3 squared is 9. The root of 3 squared is 3. And 9 times 3 is 27. Square root of 9 plus square root of 20, or 9 plus 27 is 36. So I get 6. So 6 is my r value. So again, for r, cosine of theta plus I sine of theta, we get 6 times the cosine of something plus I times the sine of something. We've got to figure out now what theta is. And so usually people figure out r pretty well. Theta usually is a little bit more challenging, but we can do it. Let's start by plotting it and see what we get. -3 plus 3 roots of 3i. So -3 would be back 3. And then 3 roots of 3i, I don't really know what that is. It's probably something, way up here. The point is, which quadrant am I in? Are you in the first, second, or third quadrant? You're in the second quadrant. So if you're in the second quadrant, that's going to affect your angle. How do we actually find the angle? We set up tangent of b divided by a. b is 3 roots of 3. I'm sorry, folks, I made a mistake here. Tangent of theta is equal to b divided by a. b is 3 roots of 3. A is -3. So we have, you can see what cancels out there is the 3's. So we get tangent of theta is equal to -√3. Tangent of theta is equal to -3, the root of 3. Where is tangent equal to the square root of 3? That's going to be at 60 degrees. 60 degrees. Okay? So that means that this is a 120-degree angle. And what is the radian measurement for 120 degrees? It is 2 pi divided by 3. 2 pi divided by 3. So we have 6 cosine of 2 pi over 3 plus I sine of 2 pi over 3. Okay, there you go. One more example, and I think, I don't know for sure, but my guess is that if there's a question running through your head right now, it's about this tangent thing. And one thing I need to encourage you guys on is, how we figure out these tangent values. Looks like my max time for 15 minutes is actually going to run out here. So I'm just going to show you this piece, then move on. But tangent at 0 degrees, tangent is equal to 0. At 30 degrees, tangent of theta is equal to the root of 3 over 3. At 45 degrees, the tangent of theta is equal to 1. And at 60 degrees, the tangent of theta is equal to the root of 3. And at 90 degrees, the tangent of theta is undefined. And that might help you. I'm in time out here, and in the next video, I'll do 3 more examples later.